you are looking at a typical controller. You have your lighting control lighting panel. Everybody knows the lighting panel. Was it 200 amp? Press the one that we did. Here's a 200 amp. And here's a 20 amp. These are typical 20 amp, 20 amp, 20 amp. All of them are 20 amp. And I'm showing just one part of it. 20 amp, 20 amp, and 20 amp. Okay, here's your lighting control panel, guys. Lighting panel interface with lighting control panel. Your lighting panel, everybody's familiar with lighting panel. It's three-phase lighting panel, right? Has a main or does not have a main. Ours probably would not have a main. It's main lugs only, as a matter of fact, because you don't need a main. And has a 20 amp circuit breakers. Most of the time we run lighting circuits 20 amps. We can run 30 and 40 and 50 and 60, guys. Not at this point. 99% of the circuits, lighting circuits you're going to be encountering are 20 amp lighting circuits. Cool? Am I good with that? So so this is, everybody's familiar with this. This is your 42 or 84 circuit breaker lighting panel. The second one that you're not familiar with is called lighting control panel. Lighting control panel, guys, have two things, two very important things. Number one, has something called a controller, exactly like your laptop in front of you, a processor, a brain to make decisions. The controller, and has multiple relays with contacts. That's what a lighting control panel in its simplest form. So can I guys get you to understand that lighting control panel actually, my friend, has a controller at the top and also has multiple relays, and you can size the lighting control panel are sized by how many relays do you want to have in this lighting control panel. Do you want a 12 relay panel or a 24 relay panel or a 50 relay panel? Does that make sense? The relays that you need to do, think of relays, guys, as switches. So I'm going to wire, so all these, every one of these that you're looking at, each one of these is a relay. One relay, two relay with one contacts or multiple contacts. Okay? So all what I'm looking at three relays here. I'm going to call this as relay 1, relay 2, relay 3, relay 4, relay 5. Or contactor 1, 2, 3, and 5. Right? 5 relays. What's a relay? You guys learned relays with us in Gary and the electrician construction. A relay is nothing but a set of contacts, one or multiple contacts, driven by a coil that you energize. Driven by a coil. Here's the coil that you need to energize the green, and here's one contact. I can have multiple contacts driven by the same coil. For simplicity, I'm showing every coil is going to drive one contact. But that's not, that you can have multiple contacts driven by one coil. Okay, here's my relays. Here's my controller. This is a 5 relay controller, right? Now I'm going to wire them. Any questions guys about the controller and the interface? This is a pipe, typically a 2-inch EMT pipe that's going from one conduit to another. 2-inch. You can have, depending on how many conductors, 2 inches good size of conductors. Typically small piece, so you don't have to do it. A nipple, 24 inches or less, so you don't have to do the rating. You just nibble them right side by side. Cool? Any question guys about these two circuits? Can I have a thumbs up, Chad? We understand up to this point before the experts come in the control circuits. So I'm going to tie, my job is to tie the two systems together. Then he will come here and talk too much about this. But before he start talking about occupancies and all this stuff, guys, we have to understand this. So this is a 5 relay control panel with a controller. The first thing you need to do for any controller, guys, is power the controller. This is the first thing you need to control it. So take this. I'm going to take a 20 amp circuit coming out of here all the way, and I'm going to go power my controller. So what do you think this circuit did? Powered the controller. And I'm only showing that's just to power the brain, like your laptop has to work. Power the controller. So you have to take a 20 amp circuit to power the controller panel. Typically 20 amp circuit. I'm showing the phases. What do you guys expect also with this another wire to go? Neutral. I'm not showing the neutral. You need a neutral. Maybe I should show a neutral for this one because the rest of them don't need a neutral. So I'm going to show a neutral coming from here. And if you guys imagine, it's going to be sitting somewhere here where the neutral is. So hot neutral 20 amp circuit to power the controller. Is the controller powered now? Yep, the controller is powered. Okay? Now when you power the controller, The first thing I want to show right here, so we power the controller. I need to show multiple lights, and because of that of interest, I'm going to show lights right here. Here's 1, 2, 3, and 4, 5, and I'm going to show these in one room, and this is in a different room. Okay? So for this room, these are 2 rooms. I'm going to call this is room 1, and this is room number 2. Okay, for room number 1, I need an occupancy sensor here. For room number 2, I need a switch, low voltage switch. Occupancy sensor and low voltage switch. Does that make sense? I decided to use an occupancy sensor here and a low voltage switch. He'll talk about why occupancy sensor, why low voltage switch in a second. Any questions, guys, about this? That's my choice. Now I need to wire these 2 rooms from this system. I need to wire these 2 rooms from this system. With me up to this point? Okay, let's do the power circuit. I'm going to use another, so I need to bring another circuit. Here's a red. If you're with me with the red, I took a circuit, and I'm going to go, just for the sake of ease, I'm going to take it from this relay. Out of this relay, look what I'm going to do. Out of this relay, I'm bringing it back here. See what I did? I broke it through the relay. Can you guys see that? And I'm bringing it now to a conduit. I have a conduit here at the bottom. Now through a conduit, I'm bringing it here, the hot, and I'm landing it here, and here, and here, and here. And the neutral, look what the neutral is going to happen. I'm going to take my neutral from here through the same conduit, here, and here, and here, and here. I have just brought the power circuit into the lights through the contactor. Can you guys see what I've done? I brought the hot, and I broke the hot through a contactor. Can you see where the hot landed? Can you guys give thumbs up, say, Chad, yeah, we know where the contactor landed? Yep. So you brought the hot only, not the neutral. And you into the panel, you broke the hot, and you brought it back so you can join the neutral to go all the way to the lighting panel, to the lights. Thumbs up, yes, we understand it. So that's what we call it, the power circuit. We have powered, that's what you did when you circuited the receptacles, power the lights. When you power the light, that's what you did, power them. Assign a circuit for them. And which relay do you think is going to control this circuit, this room now? Relay number 4. Relay number 4. Now, I haven't said anything about the control circuit yet. The control circuit, guys, I'm going to do the control circuit, and things are going to be, it's going to get a little bit interesting. So for the control circuit, I'm going to take a control circuit from here, a conduit, okay? This is for the control circuit, and I'm going to use blue this time. So the same relay, look what I'm going to have to do. I'm going to take this side of the relay, and imagine in a conduit. Are you guys with me? It's going all the way through a conduit, and I'm going to go land this one to the occupancy sensor. Cool? Up to this point, from the occupancy sensor, another wire is going all the way back. Most of the time through the, and I don't want to make it too complicated. I'm just going to show one coming in here. Oops. Coming in here. Oops, Chad, come on. Coming in here. Now it's going to go land all the way in the controller here, and from the controller it's going to come and land on this coil. Can you guys see that? Eventually it came to this coil. It's coming right into this coil through the controller. Perfect. So now when the occupancy sensor senses that somebody's moving, it closes the contact. That contact brings a signal to the controller. The controller closes in its part, closes a contact and bring a 24. This is 24 volt, by the way. This is 120/24 volt. So it will bring a 24 volt across this coil. This is 24 volt. Everybody can see that 24 volt. I brought 24 volt across this coil. What happened when you bring a voltage across a coil that the coil is rated for that voltage? Slam, shot. Now my lights are on. When the occupancy sensor, after 15 minutes, it's set or whatever you set it, it turns itself off. Open the contact here. What's going to happen to the voltage across this coil? Off. And what's going to happen to the contacts? Open. Questions? If you understand this, you're done with the lighting control panel. What Kevin is going to do is going to fill you in into all the details. This is very simple format, guys. Very simple format. So occupancy sensor is driving what relay here? Relay 4. What happened to the other relays? Well, let's go wire one more circuit and then we're done. One more circuit. So I need any question guys about this? Any question about this? Any question? Okay, so rule number 2, I decided single-handedly, Chad, Mr. Curdy, will be circuit number 1, 2, 3, 4, 5, 6, 7, 8, right? So circuit number 4, I used, which circuit did I use? I used circuit number 4 with relay number 4, right? With the relay number 4, right? Didn't I take circuit number 4, relay number 4? And I did circuit number 2, I did it LCP power. I did LCP power. This is just to identify what I'm doing. You don't have to write that one. Circuit number 2 powered the controller. Circuit number 4 went to relay 4. I have to identify. You guys are going to write a schedule called relay schedule for me. The relay schedule is going to show the circuit, what the circuit relay is going to be controlling what, and which area is going to be controlled. So which area is going to be controlled from this relay? Room 1. Done. This is called relay schedule. The circuit, the relay that's driven by the circuit or powered by the circuit, and the room that's controlled by it. And also, we add one more thing here, guys, is occupancy sensor, the type of the control in that room. 3 things in a relay schedule. The circuit, the relay driven by the circuit, the relay number, which area is controlled by this relay, and what's controlling this relay, the occupancy sensor, because it could be a low voltage switch. Can I have thumbs up that everything is cool? Cool? Ashley, my friend, you good? Tal, does it make sense? So this is a typical control circuit. Messy, yes, but that's imagine all these a 28 or 48 relay panel that you have to wire. I'm going to wire one more relay, and then the rest you guys can imagine how complicated it gets. Okay, let's take one more circuit. I'm going to take this time circuit number 3 here, and I'm randomly picking up. I'm going to go with circuit number 3 to 5, come out of 5, and you're going to see how it's going to get complicated. 5, and the best way to get out of 5 going through the same conduit, coming all the way and feeding this lighting fixture. And then I need with this circuit a neutral that's coming back and feeding this circuit. Now, what I have done, I fed room number 2 from a different circuit. I don't have to do that. I could have put them all in the same circuit, right? I decided to put room number 2 in a different circuit. I decided to put number 2 in a different circuit. Any question, guys, about that? But I landed it. So let's use the mapping here. So circuit number 3 now is controlling relay number 5. Number 5. And which room? And this in turn giving room number 2. And the type of control is what? LV switch. Low voltage switch. This is the info about this circuit. Circuit number 3 controlling relay number 5, relay number 5, right? To control room number 2. Maybe RR is not a big idea. Room number 2 through low voltage switch. Cool? Any question about the power circuit? All what you have to do is always bring the hot, break the hot, and bring it back. That's what you're doing. No neutral. Don't bring a neutral back there. Can I have thumbs up that we got the power circuit yet, Chad? Let's take the control circuit. The control circuit, let me do, again, blue for the control circuit. The same way, guys, the low voltage switch is going to come 2 wires coming out of it, at least. I'm going to land 1 wire on this side. The other wire, for the most part, goes to the controller. And from the controller, and I'm coming back into the relay. Now, these can be coupled together, and they call them come in, and I don't want to, I'm just making a symbol here. Same thing. I went to the controller, back into the relay. So what happened when you turn the switch on? What happened when you turn a switch on and off? On. When you turn the switch on, you provide a 24 voltage across this coil, and that coil will energize, in turn drive, bam, bam, drive the lower one to close, and your light in room number 2 is on. So I showed you an example of an occupancy sensor, an example of a low voltage switch. Timers are the same. Any question, guys? These are the most common ones. Low voltage switch. I will remind you the low voltage, the blue system is a 24 volt system. This means power limited technician in the state of Minnesota can install this system. What does that mean? Cheaper installation, 24, safer installation, better control system. Any question, guys, about the lighting panel compared to the lighting control panel? How they're tied together? Now, use your imagination, Tom, my friend, and map all these circuits to a relays and go across the whole building that you have. Any questions? Does that make sense, Jackson? Any question, guys? Yes, sir. That question would be for Kevin, but you can get 48 relays, I believe 60 relays, panels, a lot of relays. But Kevin will answer better than me when he comes. Yes, sir. Should we draft it in CAD and import it, this thing? Yeah. That's up to you. Kevin will show you guys there's a lot of much better looking details on sites that do control interface between the two panels. The only thing I want you guys to do is a relay schedule. A relay schedule will show a circuit that's driving a relay, that's controlling a room via some type of a control, occupancy sensor or low voltage switch or timer. Okay, before my friend comes, because he is the expert, I'm going to show you guys. Now, this is the simplest format. Now, guess what they can do? They can make this controller interface with a laptop, right? Since I have a controller now, I can have wireless or wired and interface it with computer, right? And I can send the signal. If I can capture it, because it's controller, I can send the signal from my laptop right now to turn every single light on, right? Because if you can talk to the controller can talk to all these relays. I can make any and every relay close and open at any and every time. So see, it goes bigger than that. So now this is just interface. Now you bring a signal to the controller. Inside the controller, you have the ability, they call it sweep all the light at night to save energy. So at night, around 10 o'clock, when everybody's gone home, if somebody forgot to turn the light in their offices off, so what they do is they have a signal, program the control panel. You don't have to use the laptop. You can program the control panel. At 10 o'clock, shut down every single relay in the system. So what do they do? At 10 o'clock, there's a function that goes and bam, 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 de-energize all these coils and turn every single controller, every single relay off. Questions? Same thing, I can turn relay on. If I can turn a relay off, I can turn it on via a laptop interface or directly from programming the panel. Timers. I can put a timer here that can turn this room for 4 hours only on, or from 5 o'clock, from 6 o'clock in the morning until 6 o'clock in the afternoon. You can put timers in this panel. You can astronomical clock outside, for example, for the light outside, we can put an astronomical clock that turns the light from 6 to 6 or from 6 to 7, whatever you want to set them at. You can interface in this control system anything you can imagine. If you can capture it, this where becomes the money you spend on the controller. How detailed and how powerful controller you want to have. You can have a simplest controller. All what it does is just interface these devices with the relays. Or you can have a very complicated controller that can dim the lighting system. You can interface it to dim these lights. Have a dimming ballast here and dimmer. Have that capability. And in our project, when we talk about dimming, Kevin's going to talk about dimming, guys. Light saving. You can use the light outside to control the outside light to save energy. You can put a sensor right there, so when the sun comes on, You can interface that sensor with the control panel or with the lights and turn this row of light off to save energy. The possibility of endless. And I'm going to let Kevin talk about the possibility. Can I get a thumbs up that everybody understand the interface between a lighting panel and a lighting control panel, right? That's the simplest form of a lighting control panel. Really not a whole lot to it. Any question, guys? So I hope that helps a lot from experience, guys, teaching it before the experts in control comes and talks about the ins and outs of it. In our project, I want to remind you, we have 3 things that you need to be aware of. We have occupancy sensors. I showed you how to wire it. We have low voltage switches. I showed you how to wire it. We also have timers. We have the dimming system. We have a local dimming system. The local dimming system acts like a switch with multiple wires, though, coming out of it. Think of it as a switch like this with multiple wires. And I think Kevin will touch on a little bit of details. Lithonia has tons and tons of information, guys, about control, and I'll let Kevin talk about where to find the control wiring and so forth. The last thing I want to say is power pack. There's a term you're going to hear about power pack. Power pack. If you don't have cash on you and you don't want to buy this control system, right? You don't want to buy a whole lighting control system, and you really want an occupancy sensor in this room. No lighting control panel, just an occupancy sensor in this room. You know what they do? They have a power pack. A power pack is just, see that relay here? Just that relay in a box. Just one relay in a box. And they put the box right in the center of that room. Just one box with a relay and a coil, right? So imagine, take a second. Take this relay, relay number 5, the coil and the contacts, and take them out of the panel, put them in a box, and call them power pack. Put them in the ceiling, mount them to a junction box in the ceiling, and then interface the occupancy sensor with that box, and that will give you local control in this room without a lighting control panel. What's the disadvantage? Obviously, if you have just a relay at the top here to control these lights via occupancy sensor, you can't sweep them at night. And again, the possibility now is endless. You can talk to them wireless and unreal. So, absolutely, power pack. So he's going to talk about the details in the description, guys, Kevin, in a second here. Any question, guys, about, you're going to hear the word power pack. It's nothing but a coil, a relay, just a relay, a coil and a contact. And most of the time, Tom, my friend, they don't come with one contact. They come with multiple contacts. Like you guys, the ice cube relays. Ice cube relays comes with, what is it, 8 contacts, if I remember, or 6 contacts that they come open or close. That's the same thing, guys. They can come with multiple contacts. When the occupancy sensor turns on here, I can start the machine gun in the parking lot. Oops, did I say that? Or I can turn the light on, or I can turn the air handling unit on. What they do with these contacts, they interface them with multiple things. They can make the air handling unit turn on and off from that little contact. So anyway, the possibility is endless. Any question about the interface between lighting control panel and lighting panel? Lighting control panel and lighting panel. So cool, makes sense? So what you're going to do with Chad, you're going to do 2 schedules. One schedule is the panel schedule. We do that all the time. The second one, guys, is going to be a relay schedule. The relay schedule is going to show the circuit, lighting control, the relay that it feeds, the location it controls, and the type of control that's going to happen in this relay. And Kevin will show you a sample of, I'll show you a sample of, and Kevin, of a relay schedule. Any comments, any questions, my friends? Comments and questions? Okay, I would hope that Kevin will fill the gaps. Kevin is going to talk about the occupancy sensor, low volt switches. We'll talk about the panels in a little bit more details, how they put them together and so forth. But from my experience, guys, if you start talking about occupancy sensor without showing the whole big picture, people get lost. I hope this will fill the gap. Dustin, my friend, makes sense? Anybody can tell me what type of wire can I use for the 24 volt here? Class 2 wiring. Absolutely. I can use, or can I use the HHL? Yeah, but you can, it's class 2 wiring. 24 volt, power limited, control low voltage limited. Okay, I'm gonna stop right here and wait for my friend.
He looked like a moving 60-watt light bulb. Some of you look like a little light bulb. Something with such a lens with a plasma lens that separates the sensor's field of view into several pairs of light beams. These movements cause them to enter into the pins. When this happens, the sensor registers occupancy and turns off the lens. An automatic timer, which resets every time occupancy is detected, keeps the lights on during brief periods of no activity. Once the timer expires, the sensor turns off the lights. Let's get a closer look from inside the sensor. Two laser-thin ferroelectric detector beams are positioned behind the lens. The distance between the lens and the detector is covered openly. This lens between the sides reflector beams. Experiments then monitor heat energy within each segment. Oxygen movement which drives this energy to fluctuate. The polarized picture sees this change in energy and indicates occupancy. What if the sensor can always see occupancy? Infrared reflector beams require line of sight in order to detect occupancy. But sections like walls, cubicles, and cells will block the beams. In order to detect behind obstructions, we have therefore given our sensors the ability to see around occupancy. Introducing wireless sensor. Seconded by sensor switch, this technology embeds a microphone under the sensor, enabling it to hear occupant noises, such as tapping or rushing people, or ignoring building noises. Sensors of microphone use automatic gain control to dynamically adjust the gain to loudness, once the background noise is filtered out, while leading edge noises, such as human activity, are detected as occupancy. The combination of AI with microphonics creates a touch-and-go technology sensor that both sees and shows occupants. The sensor with 3D teeth works resolution with consultation and turns on the lights. Next, the microphonics is engaged to hear sounds that indicate continued occupancy. What is ultrasonic technology? Why doesn't sensors use it? Sensors with ultrasonic technology emit high-frequency sound waves and then monitor the bounce back waves for changes indicating occupancy. Ultrasonic sensors are called a closed circuit, require good behavior justice, use more power, but most of drawbacks are low. Most importantly, faster driving speed is more effective than ultrasonic technology. Do I need to address sensor sensitivity? No. Sensitivity adjustments do not require a sensor switch. What's the time delay be set to, and do I set it? Shorter than 10 minutes, LED light can be affected. Longer than 10 minutes, energy is being wasted. Factory set at 10 minutes, install and leave alone. Sensor switch products have a microcontroller which enables digital programming with all sensor settings, such as cameras, via simple push button commands. No dip switches, drops, or any tools required. What are the different features and characteristics of a sensor? Features and attributes of sensors can be grouped into 5 main categories. Before we describe a particular sensor, reference to these categories is helpful. Sensors with occupancy sensors come in a variety of different enclosure styles that are both functional and attractive, while still being easy to use. This category specifies how sensors powered and/or switchabilities. Capture food and line voltage. Powered and line voltage. Machine line voltage switching relay. Interchangeable line and load wires. Low voltage. Powered by 12, 24 volts DC or AC. Require a power plant to switch a circuit. multiple low-voltage sensors can be used together to cover space. All of our occupancy sensors utilize beautiful air friction. Microphonic detection is included in all CDCs. The style of lens a sensor has determines its pure air arc and pattern. It is important that not all the space's air requirements are met, but also that in field application, what type of motion needs to be prepared. Specifics on each lens style are covered in subsequent videos. Several options are available in synthesis sensors, making them the most versatile in the industry. The data sheet for each sensor series lists available options. Why should I use sensors? In new construction, commercial energy fields require automatic shutter body controls, such as occupancy sensors. For retrofit projects, sensors actually do lighting feedback in most cases. Sensors also assist the lead clarification and can help clarify buildings with each task incentives. What type of sensors are for my application? Sensors for this product line is broken down into several categories of sensors which address specific applications. Details of those categories are covered in later seminar chapters. Ask questions, please. What is Android? Android is the core technology that, when integrated with lighting control devices, results in superior system intelligence. These advanced systems cost-effectively incorporate occupancy-based, weather-based, time-based, and manual lighting control. How does Android work? Android works by establishing a digital communication network between intelligent lighting control devices, including occupancy sensors, battery cells, power packs, wall switches, dimmers, and scanners. This creates a system with distributed intelligence, as well as enables global access to the building's lighting system via web-based tools and software called SensorView. What is distributed intelligence? Distributed intelligence means that all lighting control actions, such as dimming or turning lights on and off, are carried out locally within each individual lighting zone. This feature reduces the wiring requirements and associated labor costs. Additionally, distributed intelligence enables each zone of Android-enabled devices to self-commission and function independently, while still benefiting from being part of a larger networked system. The power of Androids. Androids handle control derives from the extensive level of information sharing between all devices. The best way to realize this power is to consider the depth of control it provides. Android technology enables every device's operational modes and settings to be changed remotely and at any time. This allows creation of lighting control profiles that direct how group of Android devices function for a defined time period. Profile creation and scheduling is provided via SensorView's easy-to-use web interface. The ability to reconfigure an area's lighting control multiple times throughout the day is what enables Android to deliver maximum energy savings and occupant convenience without compromise. It also offers end users innovative control scenarios and features never possible prior to Android. Let's go through a few examples from the Android-controlled building. Auto to override on. Although it's not low for the lobby lights to be in the override on state while workers are present in the building, it's impossible to predict when the first person will arrive each day. With Android, the lights can be held off until someone is detected. After normal working hours, the lights can be returned to an auto-on, auto-off style of control with a 10-minute time delay. Barring time delays. Barring the occupancy sensor time delays is a great way of picking up extra energy savings. For example, during the workday, the hallway lights may need to be overrun on, but during the early morning and evening hours, the occupancy sensors can be activated with 10-minute time delays. Later in the night, while the security guard does his overnight rounds, a 30-second time delay may be sufficient. Manual to override on. Although the first control is protected by the sensors each day as they walk through the open office cubicle area to get to their private office, Android observes the open office area lights off until someone manually activates them via the walk-light on-off switch. Even if required to keep the lights in the override on state all day, Android can always return the space to fully automated sensor control to accommodate both energy clerks and late working employees. Manual to fully auto. This powerful feature maximizes both occupant convenience and energy savings. To prevent short non-occupant visits, such as those of a second floor, from activating the lights before the office occupant arrives, the lights are held off each day until an occupant manually switches them on. When switched, the sensor assumes fully automatic on-off operation, thus preventing the occupant from having to switch the lights on again each time they return to their office throughout the day. Other control scenarios that can be incorporated into profiles include after-hours activation or deactivation of an occupancy sensor's dual technology detection, scheduled rally and seasonal adjustments of photograph backgrounds, dynamical flow control of the exterior lighting, selective dimming or overriding off of lights for load setting, the combinations are endless. What about installation and commissioning? Several features make Emerald simple and cost-effective to implement, such as self-commissioning lighting zones, auto device discovery via sensor view, optional Zigbee wireless communication, interfacing with DMS systems. Additionally, every Emerald-enabled device can be remotely upgraded, making Emerald future-proof. As you can see, Emerald technology is revolutionary in the depth of control and the level of customization it provides for any application. This, coupled with low